In this video, we are going to be talking about solubility and what makes up a solution, the different parts, and how we can distinguish different types of solutions. So while watching this video, the expectations are that this is the only thing you have open and that you are using headphones to listen. Mind your time, most videos should take no more than 12-ish minutes to complete. Take notes. So anything that's written in red or any examples that I write down should also be written in your notes. Answer any questions that are within the video or after the video, and then pause and rewind as much as you need to. Your notes will be checked for accuracy when you are finished. While we are going through these notes, we want to keep in mind the question that we answered a few weeks ago, and that is, why is oil not immiscible in water, or why does oil not mix with water? So immiscible means it doesn't mix. So our goal for this video is to be able to learn more information about solutions to help us answer this question. This video will not give you a direct answer, but it definitely will help you with answering the question. So a solution is a homogeneous mixture, which means that two or more substances are uniformly dispersed at the molecular level. So homogeneous, homo, the prefix means the same. And so what a solution is, it's just two or more substances mixed together, and when they are mixed together, they look the same. The parts of a solution, or the things that make up a solution, are the solvent and the solute. So the solvent is what is dissolving the solute. So typically the solute gets put into the solvent and then mixed together. And most of the time, the solute is a solid and the solvent is a liquid. But this is not always the case. Sometimes you have gas and gas. Sometimes you have gas and liquid. So while most times it is solid and liquid, you will have other things too. Oh, the other one is liquid and liquid. But what you want to pay attention for is the solvent does the dissolving and the solute is dissolved. And I would definitely copy this picture down into your notes as well, so you can visually see what makes up a solution. And so an example of a solute and solvent is 10 moles of KCl dissolves in 5 liters of H2O. So they are saying that the liquid is the solvent, the 5 liters of H2O. And that is because, based off of the sentence, the 5 liters of H2O is breaking down the 10 moles of KCl. So your solvent is your 5 liters of H2O. And then your solute is the 10 moles. Moles is a unit that we use to describe amount. KCl. So, again, your 10 moles of KCl, it says dissolves in, which means the KCl is what's being broken apart. So that would be your solute. And so I've been using the word dissolves a lot, and a lot of people can figure out what dissolves means. Sorry, my cat was hitting my arm. She wants me to pet her. Anyway, we kind of already have an idea of what dissolves mean, but the official definition is a substance is fully dissolved when the solute the thing that you are putting in the solvent is thoroughly mixed with the solvent. And so what that can look like is you put, for example, my solvent will be water and my solute will be sugar. Okay, I put both of those in a container. If I don't mix it and the sugar goes to the bottom, that sugar is not dissolved. But when I take it and I mix it together and I can no longer see the sugar, that would be dissolved. That would be an example of the sugar being dissolved. This picture right here shows you what it would look like if we could see the atoms or the molecules. That's not what it would see, or it's not what it would look like to the human eye. It's what it looks like on a molecular level. But you can see that all of the solute or the sugar is mixed throughout. It's not clumped at the bottom. Another word that we're gonna use in the topic of this video is solubility. So the word solubility is used to describe if a substance can dissolve and how much of it can dissolve. Okay, and there are two words that we typically use to describe the solubility of a substance. The first one being soluble. Ma'am, that is my iPad that you are walking across. Oh, you're going back. Okay. Sorry. That is the cat. Soluble means that a substance will dissolve in a solvent, that it will break apart. So, an example of something that is soluble would be sugar. Or something else that could break apart in water could be Kool-Aid mix. So if you can put it into water and mix it and it breaks apart and you can't tell the difference between the solvent, the liquid, and the solute, the solid, or whatever state of matter it is, then it would be considered soluble. It is insoluble, this is another vocab word, if the substance will not dissolve, so it will not break down. So if you were to put something that's insoluble into a solvent and mix it, you would still see it at the bottom like you do in this picture. So an example of something that is insoluble would be like an iPad or a pencil, a spoon. These don't break apart in liquid. They remain the same, so we call them insoluble. So we talked about the parts of a solution, we talked about what it means to dissolve, and we also talked about whether our solutes can be soluble and break apart or insoluble and not break apart. And the last part of talking about solubility in solutions is talking about how much can we dissolve. And so there are three typical levels when we talk about solutions. The first level, that would be unsaturated. So you have dissolved less than you are able to, and you can still dissolve more. So each liquid has a certain amount it can dissolve. And I shouldn't really use the word liquid, I should use the word solvent. Each solvent can only dissolve a certain amount. And so when it's unsaturated, I have not reached that limit yet. I can still add some, mix it, and it will dissolve. And so the key word for it being an unsaturated solution is that I mix it and it dissolves. A saturated solution would be our next level. It's when you have reached the saturation point, so you have dissolved all that you can. If you were to add more into it, it would collect at the bottom because it cannot dissolve anymore. And then the third level is supersaturated. So this level does not typically happen naturally. So in order to make a supersaturated solution and dissolve more in the liquid than the liquid can do by itself, you have to use heat. So you typically use heat to boil the solvent, and heat will help it dissolve the solute more. What happens with a supersaturated solution, once it cools, it will form crystals. Because that liquid cannot hold all of the solute that it dissolved, once the heat is gone, it actually kind of forces it out. And the way it does that is in the shape of crystals. This key thing that you want to look for in a description for it being supersaturated is that it must say that it uses heat to dissolve more and it forms crystals, because a saturated and unsaturated solution, you don't need heat to do so. And if you let a saturated and unsaturated solution sit, it won't form crystals because the solvent or the liquid can still mix in with your solute or your solid. Okay. So again, there's 3 levels. Unsaturated is like your weakest. You can still dissolve a lot more. Your saturated is you've dissolved all that you can. If you dissolve any more, it sits at the bottom. And then your supersaturated, you have to use heat to dissolve extra. And then once it cools, it'll form crystals. So over here I have, what is going on? There we go. Over here I have 2 cups. Cup number 1, based off of the picture, is I add sugar. And when I add sugar, it collects at the bottom after I've mixed it. So because it's collected at the bottom, this would be a saturated solution. It has dissolved all that it can. So it's dissolved the max amount. So adding any more will just collect at the bottom. Now, this isn't a super saturated solution because even though it's hot coffee, I don't use extra temperature. I'm not heating it to boil it. And then the other thing is, nowhere did the example say that once cooled, it forms crystals. So that's why it's not a saturated solution. That's why it's not a super saturated solution. It is a saturated solution because when I add it, I've dissolved all that I can. And so when I mix it, it won't dissolve anymore and it collects at the bottom. Cup number 2 is a little different. So I add sugar to cup number 2, I mix it in, but if I'm looking at the cup, there's no sugar collected at the bottom. So that means it still can dissolve more solute or sugar in this case. And so we would classify this as an unsaturated solution. So it has not reached the max. So these are the key vocab terms and descriptions and parts of a solution, and how we classify solutions and the parts of them. And so again, if we think back to our question of can oil and water mix, we can't directly answer that with what we learned in this video, but it can help us describe the different parts of that mixture. Solute, solvent, insoluble, soluble. So we just want to keep those terms in mind when we think about trying to answer that question in the future. So right now, after this video, you are going to complete the questions in the Google form. And then you are going to hit submit and get your answer, or not your answers, your notes checked with me.